Mike Brown, a U.S. astronomer and Kuiper belt expert, remarked that the Kuiper belt is a deep frozen record of the early history of our solar system. It is an icy region at the outermost edge of the solar system. NASA has recently revealed shocking details about what is hidden in this mysterious and little explored zone. These findings suggest that the history of our solar system might be very different from what we thought. Strange objects and a previously unknown planet could completely overturn our understanding of the cosmos. Was it a mistake to have paid so little attention to this region for so long? The Kuiper belt begins around 4.5 billion kilometers from the Sun and extends to about 7.5 billion kilometers. This vast zone forms the outermost edge of the solar system, and only a fraction of its astronomical treasures and peculiarities have been explored. Objects in this region repeatedly spark concern among scientists. In terms of width and mass, the Kuiper belt is a gigantic band of ice, rock and frozen gases, up to 20 times wider than the main asteroid belt between Mars and Jupiter, and containing 20 to 100 times more mass. The Kuiper belt also includes another bizarre phenomenon, the so-called scattered disk, a zone of irregularly distributed celestial bodies that extends far beyond the regular boundaries of the belt. The light conditions in the Kuiper belt are extremely weak, as the region is so far from the Sun that the few rays of sunlight reaching distant objects produce only a pale glow. This faint illumination makes the Kuiper belt difficult to explore, and it is also an incredibly cold environment. However, this extreme cold helps to preserve the primordial materials from which the bodies in this region have formed. Researchers believe that most objects in the Kuiper belt have not changed in billions of years, making this region a valuable window into the early days of the solar system. In addition to darkness and cold, the Kuiper belt is also a dynamic zone where many dwarf planets, such as Pluto, Eris, Haumea, and Makemake, can be found. These objects offer unique insights into the chemical composition and physical conditions of the early solar nebula from which our solar system was formed. Beyond dwarf planets, there are countless other objects, including comets and smaller icy bodies, which may contain important organic compounds relevant to understanding the chemistry of life. Despite its significance, the Kuiper belt has only been explored twice so far. Pioneer 10 made the first flyby in 1983, though it did not encounter any specific Kuiper belt objects. In 2015, the New Horizons mission ventured further into the belt after investigating Pluto and discovered the strangest object in the solar system, Arrokoth, formerly known as Ultima Thule, an object so misshapen that it contradicts some physical laws. Asteroids and comets are original relics from the early hours of our solar system, forming when the Sun was a hot and rapidly rotating disk of dust. These objects have remained unchanged in certain regions of the solar system. Researchers have found that asteroids and comets consist of a high concentration of minerals and organic substances, such as magnesium, sulfates, iron, copper, and even amino acids, which are crucial for life. Organic substances are the building blocks of life, making it astonishing that they were present in the early solar system. This challenges the idea that life conditions developed gradually, instead suggesting that life may have been intended from the beginning. Some scientists even speculate that other planets or moons could have once harbored life, as Mars may have had liquid water, and some of the icy moons could contain liquid oceans beneath their surfaces. Objects that have remained unchanged since the formation of the solar system are of great interest to science. Research into the Kuiper belt is only just beginning, and the discovery of around 2,000 trans-Neptunian objects, TNOs, shows just how much more there is to learn. Pluto, the largest of these TNOs, was reclassified as a dwarf planet in 2006 because it resembles these objects more than it does the other planets. Since then, the exploration of the Kuiper belt has accelerated, but we still know little about this vast region. Scientists have also been searching for a large planet beyond Neptune, known as Planet 9, but its existence has yet to be confirmed. The orbital anomalies of smaller Kuiper belt objects and certain irregularities in Neptune's orbit hint at the presence of another planet, but research is ongoing. Although we have studied the outer solar system for around 100 years, much remains unexplored due to the distance and faint light. Invisible objects, like those in the Kuiper belt or asteroid belt, are often first detected through their gravitational influence. The gravitational anomalies of this region were first theorized by Kuiper in the 1950s, and many objects are now being discovered. Another little-known region, the scattered disk, connects to the Kuiper belt but extends even further out into space. Objects in the scattered disk often have highly eccentric orbits, likely due to gravitational interactions with Neptune. Some comets, such as the famous Hale-Bopp comet, likely originate from this region. The scattered disk offers valuable information about the dynamic processes that shape the outer solar system. By studying the composition and orbital paths of objects in this zone, astronomers can learn more about the early conditions of our solar system. It is clear that our solar system has not always looked as it does today. Over millions of years, the objects within it settled into stable orbits. Imagine what it was like when planets were still jockeying for position, and comets and asteroids frequently collided with one another. Some scientists believe that water, and perhaps life, was delivered to Earth by comets. Though the origin of life remains a mystery, the study of these distant regions helps us piece together the story of our solar system's formation. As research into the Kuiper belt and beyond continues, we may learn much more about the early history of our solar system, the building blocks of life, and the possibilities for life beyond Earth.